The production process of PTO shafts for agricultural equipment begins with cutting and machining steel pipes to the desired size. The plastic shell is cut, printed with logos. The assembled shaft undergoes dynamic balancing to ensure smooth operation without vibration. The entire device is then coated with a corrosion-resistant layer and can withstand outdoor conditions. Workers then assemble the shell with the transmission and locking head. Gear motors, couplings, and drive components are an integral part of industrial machinery and automation systems. Gear motors combine an electric motor with a gearbox, allowing rotational speed to be reduced or increased while maintaining high torque. This makes them ideal for applications that require specific speeds and efficient energy use, such as conveyors or mixers. Couplings connect two shafts, transmitting force from one shaft to the other, while allowing for small misalignments and reducing vibration. The Philips TV manufacturing process begins with the assembly of components and circuit boards, where key parts like the screen, motherboard, and other electronics are carefully integrated. Next, the TV casing is attached, enclosing all internal components securely. The stand or base is then installed, ensuring stability and proper support for the TV. After assembly, each unit undergoes testing to ensure it meets quality standards, checking for screen performance, sound, and overall functionality. Once passed, the TV is packed with protective materials to prevent damage during transport. Finally, the TVs are shipped efficiently to global markets. Steel blocks, each weighing as much as a small truck, are first heated in a furnace to 1,200 degrees Celsius until red hot. After exiting the furnace, surface impurities are removed with high-pressure water. The glowing steel block is then repeatedly rolled between large rollers, becoming longer and thinner each time. During rolling, cooling water protects the rollers. Eventually, the block takes on a T-shaped profile, characteristic of tram rails. The long rail, about 120 meters, cools on rollers, then moves to a straightening machine. Here, heavy wheels bend it up and down until it's perfectly straight, including sideways adjustment. The top of the rail is thick for wheels to run on, while the base is flat to rest on ties and allow secure fastening. Luxfer's CNG cylinder manufacturing process begins with AFE UHD tube drawing, followed by ultrasonic inspection to detect flaws. The tube then undergoes liner spinning for shaping and a thorough visual inspection. Next, carbon fiber wrapping reinforces the structure. After that, the cylinder is cured under heat to solidify the composite. Finally, hydrotesting ensures pressure integrity before final approval. Helmke's high-voltage coil production starts with custom design using simulation software to meet specific voltage, 3,000 to 13,800 volts, and power, 200 kilowatts to 20,000 kilowatts requirements. High-quality copper or aluminum wire, insulated with mica or polyamide, is wound on automated machines for precision. Coils undergo vacuum pressure impregnation, VPI, with epoxy resin to enhance insulation and durability. Rigorous testing, including insulation resistance, high voltage, and partial discharge tests, ensures compliance with IEC standards. Coils are then assembled into motors or transformers, with final checks guaranteeing reliability. This process, leveraging advanced automation and quality control, ensures Helmke's coils meet stringent industry demand. The high-speed blanking press SA315 is a fully automated system designed for the high-efficiency production of rotor and stator stacks. The process begins with loading the double decoiler, followed by automated strip insertion into the press. Once the die is initialized, the machine enters a continuous run mode, enhanced by a contactless strip thickness measurement device for precision. The Schuler interlocking control ensures synchronized operation. Finished stacks are removed automatically, both rotor and stator stacks. All components are fully integrated into the central press control system. A motorized movable bolster plate, segmented bolster plate, and retractable die-changing consoles allow for quick setup changes and flexible production. The manufacturing process at Florahalli, one of Turkey's leading carpet producers, is a highly integrated and well-controlled operation combining modern technology with strict quality standards. Production begins with the yarn manufacturing phase, where raw materials are processed into high-quality yarns. These yarns form the basis for durable and aesthetically appealing carpets. Next is the design phase, where Florahalli's in-house design team uses advanced software to create patterns ranging from classical to modern styles, reflecting global interior design trends. Once the patterns are finalized, the yarns are fed into automated weaving machines, which transform them into carpets according to the pre-programmed designs. This phase requires high precision to ensure the patterns are perfectly woven without defects. After weaving, the carpets undergo a series of surface treatments such as cutting, brushing, and vacuuming to enhance softness and finish quality. Before packaging, each carpet is subjected to a manual quality inspection to check for any visual or structural flaws, ensuring only flawless products reach the market. Finally, the finished carpets are carefully rolled and packaged for shipment to both domestic and international customers. Florahalli also emphasizes environmentally friendly practices throughout its production process, aligning with principles of sustainable manufacturing. This comprehensive workflow ensures that every Flora carpet meets high standards of durability, beauty, and customer satisfaction. The DMG Mori CTX Delta 6000 TC is a high-performance CNC turning center designed for large and heavy workpieces, commonly used in industries such as marine, power generation, and heavy machinery. It features a 1070 mm maximum turning diameter, a 6150 mm maximum workpiece length, and can handle up to 7,000 kg. Equipped with a high-power main spindle, a plus or minus 120 degrees B-axis, and a 50-tool automatic tool changer, it offers simultaneous 5-axis machining. The machine is ideal for complex parts, providing high precision and enhanced productivity with multi-side machining and reduced setup times. The Zeman SBA Compact is a robotic beam assembly and welding system designed for efficient and precise structural steel fabrication. It utilizes advanced automation technologies to streamline production, ensuring high-quality outputs and reduced labor costs. The system is powered by the Profit software, which automates the assembly and welding process by generating workflows directly from 3D data, eliminating the need for manual programming. A key feature of the SBA Compact is its robotic assembly and welding, which includes a robot for tack welding and finish welding, ensuring consistency. The system is equipped with a laser measurement unit to define material dimensions and locate the reference point for precise processing. Additionally, the parts scanning unit performs a quality check on add-on parts, comparing them to the 3D model for accuracy. The parts robot positions these parts at their exact weld locations, while the integrated profile turning device allows for 360 degrees rotation of beams, enhancing production efficiency. The profile clamping unit ensures stability during welding. All these functions are controlled by an automated system that allows for remote monitoring and operation, improving safety and efficiency. With its compact design, the SBA Compact fits into facilities with limited space, and its modular design allows for future upgrades. The Olympia 80 Tube Mills HF Cage Forming System is a cutting-edge solution for producing high-quality welded tubes, particularly square and rectangular profiles. This innovative line employs a linear cage forming technology, allowing for rapid size changes without the need to replace rolls, significantly reducing downtime and tooling costs. Olympia 80. The system features 74 independent axes, each driven by hydraulic motors with computerized control, enabling precise adjustments across the forming, welding, sizing, and straightening stages. This automation ensures consistent tube dimensions and enhances overall production efficiency. Additionally, the line incorporates a flying shear cutting system, allowing for continuous operation and minimizing material waste. Designed for versatility, the HF cage forming line can produce tubes with dimensions ranging from 30 by 30 millimeters to 200 by 130 millimeters and thicknesses up to 8 millimeters, catering to various industrial applications. The fabrication process of a 3-inch wire rope sling begins with measuring and cutting the wire rope to the required length. Skilled workers then manually weave the strands to form the desired configuration. The rope ends are carefully prepared and fitted with reinforced steel sleeves for added durability. Using a hydraulic press, heavy-duty aluminum ferrules are swayed tightly onto each end, creating permanent eyes for secure lifting. This process ensures both strength and reliability in demanding industrial applications. The manufacturing process of a 200L steel drum involves several precise and sequential steps to ensure durability, leak-proof performance, and compliance with industrial safety standards. The process begins with steel sheet forming, where cold-rolled or galvanized steel sheets are cut to size and fed into a rolling machine that bends them into a cylindrical shape. The longitudinal seam is then welded using high-frequency electric resistance welding or arc welding to securely seal the body of the drum. Following this, the drum passes through the beating process, where several reinforcing ribs or beads are rolled into the body. These strengthen the structure and help prevent deformation under pressure or impact. In the lid assembly stage, the top of the drum is installed, either by welding for tight head drums or by crimping for open head types. The appropriate fittings, such as bungs, plugs, or locking rings, are also attached and secured at this stage. After assembly, the drum undergoes surface treatment and coating, typically by powder coating, spray painting, or epoxy lining to protect against corrosion and chemical reactions. Finally, a thorough quality inspection is performed. Each drum is pressure tested for leaks, visually checked for dents, weld integrity, and coating uniformity. Only drums that pass all criteria are released for packaging and shipment. The company continuously enhances product quality and production efficiency through ongoing R&D and sustained investment in automation and precision manufacturing technology, ensuring that each drum meets international standards and adapts to evolving industrial needs. In Bobo Dioulasso, Burkina Faso, the process of handmade aluminum pot manufacturing is carried out using the traditional green sand casting method. This technique involves creating molds from a mixture of sand and clay, which retains shape well when compacted. First, a model of the pot is made from wood or metal to form the exact shape of the desired product. The model is then pressed into the sand mixture to create a negative mold, which is then removed, leaving a hollow space in the shape of the pot. Recycled aluminum alloy is melted in a small furnace and poured into the sand mold through channels. Once the aluminum cools and solidifies, the sand mold is broken to retrieve the finished product. Since each mold is used only once, this process must be repeated for every new pot. These handmade aluminum pots are commonly used in most households in Burkina Faso and are widespread across West Africa. The upright roll forming machine for a Vietnam client features a production speed of 0 to 20 meters per minute. It includes flying shear for precise cutting, and the widths are adjusted automatically to suit varying requirements, ensuring efficient and flexible production for different projects. Nordex's manufacturing process for nacelles and wind turbines begins with an efficiency program aimed at preparing for future market demands. To achieve this, Nordex transitioned from dock assembly to synchronized continuous flow production. The company chose a rail system with friction wheel drive and adapted the technology to fit the existing hall layout. The most suitable solution was a skid system with a right-angle deck designed to handle heavy weights. Nordex set up 6 production lines for key components, including machine and generator supports, the main nacelle line, the drivetrain line, and lines for the hub and pitch reinforcing elements. This change significantly improves production efficiency, reduces cycle times, and tripled production capacity, increasing from 330 turbines per year to around 1,000 turbines in a 2-shift operation. Abaji robotic welding simplifies the welding process for excavator buckets, which are traditionally manually welded due to their unique designs. The process begins by selecting the welds and defining welding parameters. Next, the part is scanned to ensure accuracy, and then the robot carries out the welding process, completing it swiftly and efficiently. Traditionally, each bucket requires new programming and significant time for teach pendant programming, as there are numerous weld types and the need to synchronize the robot with the positioner. Additionally, metal bending causes deviations. With Abaji, robotic welding becomes efficient and quick, as the system automatically generates the robot's path in minutes, eliminating the need for manual programming. This system reduces setup time and increases production speed, providing a reliable solution for welding excavator buckets. The manufacturing process of a drum barrel begins with cutting and preparing materials. Drums are typically made from steel or plastic, with steel sheets cut into circular shapes and long strips. These sheets are then formed into a cylindrical shape and welded together to create the body of the drum. Next, the edges of the drum are rolled to form rims that will connect with the lid. The lids are fabricated separately, usually from steel or plastic, and then attached to the body using welding or screws and fasteners. In some cases, the drum is coated with paint to enhance its resistance to corrosion and improve its appearance. Finally, the completed drum undergoes a quality check, which includes testing for tightness, strength, and load-bearing capacity to ensure durability and safety. Once verified, the drum is ready for packaging and shipping to customers. An aluminum foil rolling mill processes aluminum into thin foil sheets by rolling, stretching, and compressing metal under high pressure for packaging and industrial applications. The semi-trailer production line at Vehicle Master utilizes several key machines. Laser cutting machines are used for precise metal cutting, ensuring accurate part sizes. Automatic MIG/TIG welding machines weld metal components to form the frame and other critical parts. Hydraulic presses are employed to shape and process metal parts with high precision. Automated assembly machines assist in assembling parts like axles, suspension systems, and wheels. Quality control machines are used to check the durability and safety of the components. The automatic painting machines apply protective coatings, and automated packing machines prepare the final product for shipping. An excavator destroying a car typically involves using the machine's powerful bucket to crush the car's body, smash windows, and drop it from a height to simulate heavy impact or destruction. The metal casting process at Norte Foundry begins with melting metal in a furnace. The molten metal is then poured into sand molds to shape components according to technical specifications. After cooling, the parts undergo quality inspection, surface treatment, and mechanical finishing if needed. Finally, the finished products are packaged and shipped to customers.